Good day, everyone.
Good day.
It is.
All right, so today we're going to be taking a look at graphs of waves. All right, so graphs of waves. And this should take us to the end of the introduction to waves. Remember, all of this was just an introduction to waves. Right, we spoke about the velocity, the general equations governing the waves, the type of waves, examples of waves, and whatnot. Right, and we look at some wave parameters as well. Right, if you do not know what I'm talking about, they can check for the previous videos on those topics. Okay, so graphs of waves. Right, so there are two types or two graphs that we will be discussing. Two types of graphs. We have a displacement position graph. So there are two types of graphs. So the first type is displacement position graphs. And anyone know what this is? What is a displacement position graph?
No, sir.
No. Okay. Okay, so a displacement position graph. So a displacement position graph relates the displacement of each point in a wave to the distance or position from some reference point. Okay, so now notice that this displacement position graph has no time in it. So this is at one instant in time. Okay, so this is at one instant in time, or time is held fixed, right? So we want to know what the wave is doing at one instant in time. So the example would be, so let's see an example of it. So suppose I said that the graph below shows a wave of speed 32 meters per second. Okay, at an instant in time. All right, lovely. All right, and they want me to determine the first one they want me to determine is the amplitude. Let's remember the amplitude, what the amplitude is. Anybody can tell me what the amplitude is? Anyone?
Yeah, it's highest point of displacement of the wave.
Right, is the maximum displacement of the wave, right? So the frequency and finally the period. Okay, cool. So this is what they want me to find, and this is the graph they gave us. Right, so we have all right, so the points would be, this would be 0, this would be 5, this would be -5. This was 40, 80, 120. This was displacement in meters. No, sorry, millimeters. And this would have been position in centimeters. Okay. So the amplitude of this wave will be what? What will be the amplitude? What is the maximum displacement? Look at which axis is given displacement. Right, so what will be the maximum displacement? Right, so the maximum displacement will be 5, right? Because that is the largest displacement from the rest position, which is 0. Right? So notice that this distance here is 5. This distance here is also 5. This the distance from the rest position is 5. So the amplitude is 5 millimeters. So A would be 5 millimeters. Part B would be, now the wavelength, right? Remember the wavelength is, well, this time wavelength will be given in centimeters, but you could convert it, right? So what would be the wavelength of this wave? Anybody remember how to find wavelength?
Yeah, it's a measure of a full wave from the highest point to the lowest point.
Okay. Well, it's for one complete cycle, right? So it could be from here to here. It could have been from here to here. It could be from here to here, right? So what is the wavelength of this wave?
80 centimeters.
80 centimeters, yeah. So this would be 80 centimeters, or you could put it as 0.8 meters. Okay. And from this, can we calculate the frequency? Well, they told us in the question that the wave is traveling at 32 meters in a second, right? So we know the velocity. So part C, which is asking us for the frequency, we have V is equal to F lambda, right? And from this, we can see that F is equal to V over lambda, right? By dividing both sides by lambda. And we know what the velocity is. The velocity is 32 meters per second. Okay, so we have 32 meters per second divided by 0.8, which will give us how much?
48.
48?
No, 40.
Okay, cool. So this is 40 hits. Okay, okay, lovely. And then from this, can we find our period? What is the period?
The period is T is equal to 1 over F.
1 over F, good. And that will be 1 over 40, which is equal to, well, this is simple, 0.025. Right, it's just a quarter divided by 10, so 0.025 seconds. Okay, lovely. So all you understood this example?
Yes,
Right?
sir.
Okay.
Yes, sir.
Right, so remember to go back over it if you didn't understand, right? And try to convince yourself of these things. Right, so the other type of graph is a displacement time graph, right? So displacement time graph, Okay, so what is a displacement time graph? Well, this is similar to a displacement position graph, but just this time, the position is held fixed and it is allowed to propagate through time. Okay, so a displacement time graph relates the displacement of one point. Now notice that this one up here was, 1 second. This point up here was for each point. And this one that we're doing now is for one point. Right, remember the position is fixed. So that we cannot talk about different points. Right, of 1 point in the wave as time continues. Right, and of course, position is held fixed. Is held fixed. All right, so let's see an example of this one, just like before. So the graph below shows a wave of speed 40 meters per second. Okay, and they want us to determine, so A, the amplitude of the particle, part B, they want us to know the displacement of the particle, part C, the period, part D, the frequency, and part E, the wavelength. All right, so lovely. So this is what we have. All right, so let's just draw the graph. Okay, so this is displacement in millimeters. And this is time in milliseconds. Right? And we have our graph looking like this. Right, so we have this being 10, 5, 0, -5, 10. This is 100. This is 200. And this is 300. Cool. So what is the amplitude of the wave? Right, and they tell us that the particle P is right here.
Yeah,
Right, sorry,
I
I
think
forgot
it's,
that.
it'll be the 10 millimeters.
Yeah, it will be 10, right? Because this distance here is 10, right? 10 millimeters. Okay, lovely. So the displacement is 10. So that is part A. 10 millimeters. And what is the displacement of particle P?
Five.
Well, not 5. Remember, displacement is a vector quantity. So we have to take in consideration direction, right? So it will be what? Well, -5. Right, so it will be
Negative 5.0.
Right, so negative 5.0 millimeters. Right, so part C asks us for the period. So the period will be what? Well, the period is the time taken for one complete wave, right? So that the one complete wave could be from here to here, from here to here, from here to here, and so on. All right, so what is the period of this wave? The one complete wave is from this point to this point. So the period will be 200 milliseconds. Right, which we could convert by dividing by 1,000 to be 0.2 seconds. All right, I hope all understand where the period came from. Okay. Part D, they want to know the frequency. Right, so the frequency is equal to what? How do I find the frequency in this case? How do I find the frequency in this case?
Yeah, the frequency is equal to 1 over t.
Yeah, 1 over t. Right, so this is equal to 1 over 0.2, which is equal to how much? Well, it should be 5 hertz, right?
Yeah.
Right, cool. This is 5 hertz. And finally, part E, the wavelength. So they want to find the wavelength. Now, if you read the question carefully, they tell us that the graph below shows a wave of speed 40 meters per second. So since we know the velocity, we have v is equal to f lambda. Okay, so we could solve for lambda by dividing both sides by f. So we have lambda is equal to the velocity of the wave divided by f. The velocity of the wave was 40 meters per second. The frequency is 5, right? So, and 40 divided by 5 is 8 meters, right? So this would be 8 meters. So the wavelength will be 8 meters. Did you all understand this example?
Yes.
Yes, sir.
Yes, sir.
All right. So that concludes today's class. All right. So next time we come, we will be taking a look at sound waves. But for our asynchronous class tomorrow, we would be doing some extra questions on these things, and that's what we covered already. All right. So I'll see you all in tomorrow's class.